And okay, let's start with the summary for week 3. The first thing, and if there's anything that you have a doubt in while we're discussing things, you can just unmute yourself and ask. Let's start with what does a quadratic function look like? Let's say you have, so a quadratic function looks like this. This is the general form of a quadratic function where x is the variable and your a, b, c are obviously they're called coefficients of the terms x square and x, and they are arbitrary, right? So in this equation, they're arbitrary. That means you can once choose them and then fix them, and that will give you a unique quadratic equation. So this is a quadratic. This is a quadratic function. And what does your function looks like on xy axis? So if this is your xy axis, then your function looks like this, or like this. What your function, this function, quadratic function looks like. Next, we have the axis of symmetry, what's called the axis of symmetry. For quadratic function. We just saw that a quadratic function looks like this. So the axis of symmetry is basically a line. So if your function looks like this, then it's basically a line, obviously parallel to your y-axis, such that when you fold, let's say this is a paper, and if you fold this paper along this line, then this side should overlap with this other side. They should coincide with each other. This point should coincide with this one. This one should coincide with this one. While when you will fold this thing along this line. That's called your axis of symmetry. What's the equation of axis of symmetry? It's given by, obviously, it's a line. Firstly, what should it look like? This is a line parallel to y-axis. So what should this line, what do you think should be the equation of this line? Can we say anything about the equation of this line? This is called the axis of symmetry.
X is equal to A.
Yeah. So the form will be x equals to a, right? Where a is any constant. You could have said, yeah, it's any constant. It's not the same a as the one that we wrote in the quadratic equation. So, and in particular, your x is equals to minus. So, if your quadratic function is, if this function is ax square plus bx plus c, if your function is this, then the axis of symmetry is given by x equals to minus b by 2a. For example, let's say this is your axis of symmetry. So let's say you have 2x squared plus x plus 3. If this is your quadratic function, then axis of symmetry is x equals to minus b. So a minus b here is minus 1 and a is 2. So it's 2 times 2, you'll have minus 1 by 4. That's your axis of symmetry, minus 1 by 4. And next up, we have vertex of a quadratic equation. Vertex is basically, let's say you have this thing. Graphically, it means this thing. You have this, then we know this is called the axis of symmetry. This is the axis of symmetry. And the point where your axis of symmetry and the quadratic function intersect, that's called your vertex, right? Now, let's say your function is, again, we're taking the same general form, ax squared plus bx plus c. Then, and the other function So vertex is basically the point of intersection of this line, the axis of symmetry, and this function, quadratic function, right? So it should be where this function intersects this line, x equals to minus b by 2a, right? So it should be, this point should be the point of intersection of this line and this curve, right? And how do you find the point of intersection of these two curves? If this is one curve, this is another curve, then how do you find the point of intersection of two curves?
X replaced by minus b upon 2a in fx.
So you put this x here in this equation, right?
In
Or
function,
basically,
yes. Put the value x in function, no, ma'am?
yeah, right. So you put this value in this function, right? So it will become f minus b by 2a, right? So just 1 second. So your vertex becomes the x coordinate of the vertex, obviously, of this point. The x coordinate is going to be minus b by 2a, and y coordinate is going to be this, right? So your point of intersection of these two curves, or you also call it vertex, becomes x comma fx, or you can just say your vertex is minus b by 2a, comma the function's value at minus b by 2a, right? And next we have this thing, whether you're, because this is also a parabola, this is also a parabola. So how to identify if it's an upward parabola or a downward parabola? So let's say you have ax squared plus bx plus c, and your a is greater than 0. Let's make two cases here. Let's say this is your function, and your first case is your a is greater than 0. This should mean that you'll have an upward parabola. Why does that happen? Let's say you have ax squared plus bx plus c, right? And let's say you, now either your function is going to be something like this or something like this. How do you decide this? And this is a function which goes from minus infinity to, from your x is extended from minus infinity to plus infinity, right? So let's check the limit then of this function at x, limit as in when your x goes to infinity. Your fx goes to, so this is your fx. So if this x goes to infinity, that means this, if this x has a positive sign and if it keeps increasing, then this will be a x square, where your x square is positive, then bx, where your x is again positive, and then c, right? X is positive, x square is positive, so this entire thing will give you, and this c is just a constant, right? So if this entire thing goes to infinity, if x goes to infinity, that means your x square also goes to infinity, ax square also goes to infinity, because your a is positive. A is also positive, x square is also positive. And eventually what happens is your x square, when your x tends to infinity, your x square is greater than bx. Or you can just say your x square is greater than x. So that means when your x, does this thing make sense to everyone? When your x tends to infinity, your x square is greater than x. That means if you take large numbers, for very large numbers, x square is greater than x, which is actually always true unless you take x to be between 0 and 1 or minus 1 to 1. So for positive numbers, greater than 1, x square is always greater than x, right? So if your x is going to tend to infinity, that means eventually your x is greater than 1, right? That means your x square should be greater than x. So the focus should be on the coefficient of this. That's what I'm trying to say. The coefficient of this is not going to impact things because x is smaller than x square when your x tends to infinity. That's why the coefficient of x square decides the uh, upward or downward parabola. Is this okay? This goes to infinity. And even if your x goes to minus infinity, because x square, if x goes to minus infinity, x square is going to go to positive plus infinity, right? So this term is going to go to plus infinity. If your x goes to minus infinity, ax square goes to plus infinity. And bx and c sign does not matter. Reason being, because your x square is greater than x, where x tends to infinity or minus infinity. Is that okay? Does anyone have a doubt in this thing? This is going to go to infinity, provided your a is greater than 0. The second case is when your a is less than 0. That means it's downward parabola. Which is, it looks like this. And this one looks like this. It could be this or it could be this. Depends on other factors, but it will open upwards. That's what it means. If a is greater than 0, parabola opens upwards. And if it's less than 0, then it opens downwards. The next point is the slope of your parabola. So if we're taking the general form ax square plus bx plus c. So slope of fx equals to ax square plus bx plus c at, let's say you have to find the slope at x naught, y naught, right? Then it is 2a x naught plus b. So the for general slope is this. Ax plus b. But if you have to find the slope at a particular point, let's say you have to find the slope at x equals to 2. So in particular, slope at x equals to 2 is 2 times a, 2 plus b. So this will give you 4a plus b. That's the slope for this function. And we only need x to find the slope, right? Nowhere do we need the point y. But if you, okay, that's not needed. Let's move ahead. And then the next thing that we have is the distinction between roots and zeros. So let's say this is quadratic. So roots are of an equation. So basically when we discuss roots, we discuss them for equations. What does that mean? Let's say you have an equation fx equals to 0. Then the x that satisfies this equation, this is an equation, right? Because it has an equal to sign involved. So roots of equations are x such that fx equals to 0, right? And then comes the zeros. Zeros are of the functions. We talk about 0 when we just have a function. So zeros of fx are values x such that fx equals to 0. They look like they're the same thing, but when we talk about what's the difference, the significant difference between them is that roots are discussed when you're talking about equations, and when you're talking about a function, you say that they're zeros. Okay. And how do you find the zeros of fx? Where fx is the zeros of, what do zeros of a function geometrically mean or graphically mean? Let's say your
Graphically,
function,
there are the x-intercepts.
right? So they are the x-intercepts of fx, right? Where a function or this looks like this. If this is your function, then the points where it cuts the x-axis, these are zeros. They're all zeros, right? This is fx. Then how do we find the zeros? So in this one, in week 3, we'll particularly be discussing about the zeros of, we'll only be discussing about zeros of quadratic equations. So how do you find the zeros or x-intercepts of a quadratic function? So let's say you have a quadratic. So there are methods to find the zeros of quadratic function. Let's discuss them one by one. So the first method is factoring method. What do we do in factoring method? We try to convert it into factors. Let's say you have ax square plus bx plus c as your function, and you have to find the zeros of it. That means you have to find the value of x such that this thing becomes 0, right? What you do is you convert it into this form, x minus k1, x minus k2. Write it in this manner. And then these are the zeros. K1 and K2 are zeros. You can say roots of the quadratic equation. Let's take up an example. Let's say you have, and how do you use this factorization method? So in factorization method, to find this K1 and K2, what you do is, you have this rule, let's say you have two roots, K1 and K2. Then the product of K1, K2, or wait, first you take the product of these two, that's the coefficient of x square, A, and coefficient of the constant term. So it's this AC. And your AC is equals to alpha beta, where your alpha, let's say alpha beta are required roots. Let's call them alpha and beta. Then they say that the product of alpha beta is equals to the product of AC. Or actually, these are not even roots yet. Wait. We're trying to find two numbers. In this factorization method, we need two numbers, alpha beta, such that the product of alpha beta is equals to AC, A into C. And the sum of alpha beta is equals to B. So we need two numbers, alpha beta, such that the product of alpha beta is equal to AC, and then the sum of alpha and beta is B. So what we do here is we try to write Let's do an example that would make things more clear. Let's say you have this thing, this quadratic equation 2x squared plus 2x minus 12 equals 0. Then you need two numbers. We're looking for two numbers such that their product is equals to alpha beta. Product is equals to 12 into 2. Minus 12 into 2, that's minus 24. And their sum should be equal to 2. Right? What do you think would be those two numbers whose sum is minus 24 and their product, the sum is 2 and their product is minus 24? So let's see how we do this. We have two numbers, right? And this is coming out to be minus, the product is coming out to be minus 24. We need two numbers whose
4 and 6, ma'am.
6 and minus 4.
4 and 6, the sum would be 8. And the product is also not minus 24.
6 and
Let's
minus
take
4.
obviously we can do
minus
this. Let's
6.
try it. Let's come to find some logic. Let's try to find some logic in this. We know that the product of two numbers is only negative when one of the numbers is negative, right?
Yes,
So
ma'am.
it's so we 100% know that one of these numbers has to be negative and the other one has to be positive, right?
Yes, ma'am.
And then we factorize 24. So let's try to factorize 24. The possible factors would be, let's start with 1 and 24. Then you have 2 and 12. Then you have 3 and 8. Then you have 4 and 6. And then you have, and then the things are, I think, going to repeat. So then you will have 5 is not there, then 6 and 4. Then 7 is not there, 8 and 3. So the things are going to repeat, right? After this point, they're going to repeat. So let's keep these 4. And we know that the sum is 2. So the sum, one of the numbers is negative. This implies, let's say alpha is greater than 0 because this is symmetric, right? It's alpha, beta, beta, alpha. So you can choose one of them to be greater than 0 and beta to be less than 0. And this says that the sum is equals to 2, which means that one number is, the bigger number is obviously positive and the smaller number has to be negative, right? So this is going to be, if you do bigger number positive, smaller number negative, you will get 23 from here. This is, you will get 10 from here. From here you will get 5 and from here you will get 2. That means this should be the correct pairing, right? That means 6 and 4 should be there with 4 negative and 6 positive. So this will give you minus 4 into 6 minus 24 and minus 4 plus 6 equals 2. And then what you do is you have 2x squared plus, you try to write this 2x as the sum of these two because it's the sum of minus 4x and 6x, right? You found two numbers minus 4 and 6. So you write this as minus 4x plus 6x. So this thing becomes 2x squared minus 4x plus 6x minus 12 equals 0. And then you club these two together and these two together. And then take the common, whatever you find common between these two, just take that out. We know that 2x is common.
2x.
We have 2x, so we'll be left with x minus 2. And here 6 is common, we'll be left with x minus 2 equals 0. And if you will just use your distributive property, so you can have this as 2x plus 6 and x minus 2, right? Distributivity works like this. 2x goes with x minus 2, then 6 goes with x minus 2, right? And you get this thing. So we have factorized these two things, right? From here, it should be x equals 2. And to find the roots, you can put each of these factors equals to 0, right? Because if this is, and these are all linear factors, what this means is that if you have x squared, if you have, let's say you have a quadratic factor here and a linear factor here, right? And if this thing is equals to 0, that means this only means two things. Either your linear factor is 0 or your quadratic factor is 0, right? Because if none of these is 0, then the product can't be 0. But for quadratic factor, there could be more possibilities from here, right? Because it's not a linear factor. In linear factor, you're sure that x minus 2 is only 0. If you have x squared minus 2 here, then you know that this can be 0 at 2 points. There's not just 1 point. So the surety is, or if you have both linear factors here, you can simply say that this is 0 if and only if 2x plus 6, either this is 0 or x minus 2 is 0, which is either your x is equals to minus 3 from here or your x is equals to 2 from here. Now you don't need to put minus 4x first and 6x. The other way could be, you can do 2x squared plus 6x minus 4x minus 12. That works too. Then you
Yes,
club these two together.
Or we
And-
can do is that we can divide that whole 2x square plus 2x minus 12 by 2, and then the answer would be x square plus x minus 6, and then we could
Yeah,
simplify.
you can do that too. Yeah, you can take 2 common because 2 is everywhere, here, here, and here. So you can take that common too. And then it would be easier for you to factorize two, to split them into 2 parts. That will be easier.
Then minus 3 and 2 will be
Yes.
only the answer.
minus 3 and 4 will be the answer.
Right. So
No,
first thing
ma'am,
is
minus 3 and 2 will be the answers if we do
minus
like
3,
that.
it will remain the same. No, you're just taking out
Yes, ma'am.
common thing, not going to change anything. So let's say you have, all I'm trying to say here is you can take this minus 4x first and club this with 2x square. That works too. Or you can take 6x first and club this, and then take everything common from here and everything common from here. It'll give you the same answer. First thing is this, and then the second thing is, let's say you have, let's do another example on this. This one we just quickly go through. This is, let's say, 12x squared minus 7x minus 10. Now there's nothing common here, so you'll have to solve this thing only. So it says we need 2 alpha beta, such that alpha beta, product of alpha beta is 120 minus 120, and sum is minus 7. So you need 2 numbers whose sum is minus 7 and product is minus 120. So this, now because you have a negative sign here, this again means that one of them is greater than 0, the other one is less than 0. And this means, because you're getting a negative sign here, so if alpha is greater than, so the one whose mod is, let's not get into this one. Let's just try all of the factors. So
Minus
if you
8
will try
plus
to factor
15.
120,
15 into
Minus 8 plus 15.
minus 8, let's try to see the possible factors because it doesn't click right away, right? So 120 is of no use. 2 and 60 are too far away. 260, they're too far away. Then 3 and whatever with it, this is also very far away from each other, so that their sum cannot be minus 7. Then 4 and we'll have 30 here. That's also too far away from each other. Then 5 and we'll have with 5, what do we have with 5? 2 and 4. They're also, the difference is also not 7 or minus 7. Then you will have 6 and this will be 20. Their difference is also not minus 7. And then we have 7's not there. Then we have 8 and 15, right? So if you
That would
take
work,
the
ma'am.
difference, yeah, so if you take the difference, you'll get 7, or if you take this negative and this positive, you'll get minus 7. That means plus 8 and minus 15 is going to work. So if you take alpha, if you take the sum of these two, you will get minus 7, and if you take the product of these two, you get minus 1, 2. So this works. Now you try to, what was this, was it, right? 12x square minus 7x minus 10, and you split it into two parts. So you can write minus 7x as plus 8x minus 15x minus 10 equals 0. Then club these two together and these two together. So from here, the common thing will be, I guess, 4. And you will have 3x squared plus 2, 4x actually. And from here, the common thing will be 5. So this will be 3x plus 2 equals 0. And when you club them together, this one and this will be 4x minus 5. And this is 3x plus 2 equals 0. This is 0 if and only if either your x is equals to 5 by 4 from this factor, or x is equals to minus 2 by 3 from this factor. Then we have the second method, which is completing the squares. So in completing the squares method, let's say you start with this thing, ax square. What we try to do is, in this one, we try to make this thing a square, like this thing, x minus, let's not call it a, let's call it k, because a is already there. So this is x minus k square plus something equals 0. We're trying to do this thing, which is possible, and we'll see how this thing is possible. Let's see. So we want to have a square factor here. First thing that we do is, step 1 is divide this entire equation by a. So you will have x square plus b by ax plus c by a equals 0. And the next step is, let's just write it here, and take the constant on the other side. This is, eventually you'll have to take the constant to the other side, so we're just doing it now. So this is it, and then you take the constant to the other side, which gives you this. If you don't do it now, you'll have to do it later. So let's do it now. Makes things cleaner. So now you have this thing, and you have to convert it into a factor, this x minus a square factor, x minus k square factor, right? We already have this form. If you, okay, let's say if you have something like x, we want to make this thing as the square of something, x minus k square, right? How do we do this? We do this as, if you open this, you'll have x square minus 2kx plus k square, right? This is a constant term. Without x, you can add these things here. That's fine. And here you multiply this thing with k with 2, right? So which leads us to this thing that we should be dividing this thing, because if you have anything here, any constant here, then this thing is going to be the square root of that thing multiplied with 1 and then with multiplied with 2, right? So to find that constant term here, what we do is we divide this thing b by a. Divide coefficient of x, that is b by a, by 2 and add the square, or you can just simply, instead of doing all this, we can just simply say add square of b by 2a. Here you have b by a. Divide this thing by 2, so you'll get b by 2a, and add the square of b by 2a on both sides of the equation. So this will give you x square plus, why are we dividing it by 2? Because if you have b by 2a squared here, then this is the square. You're adding the square on both sides, right? First, let's get done with this thing. This is what you get. Adding the square. And why do we add the square of this on both sides? Because this now becomes a perfect square. It's a perfect square of x minus b by 2a. Squared. So you'll have x squared plus b by 2a squared, and then 2 times x into minus b by 2. That gives you, because you have a plus here, so you should have taken plus. If you have a plus here, take plus. If you have a negative sign here, you will be taking negative, right? So if you open the square of this, it's exactly this thing. That's why we divided it with a 2. So that when you will do 2 into x into b by 2a, this 2 and this 2 will get cancelled, and you will get this term b by
Can
b
you
by a.
explain this again? X plus b by 2a the whole square.
What we're trying to do here is, in this, why do we add b by 2a square? This thing is, so till the previous step, everything is clear, right? Till this step.
Yeah.
Now what we do in this equation is, on both sides of this equation, we add the square of b by 2a. What and why do we do so? Because now this thing becomes a perfect square. Perfect square means this is exactly the same as x minus b by x plus b by 2a whole squared. When you open the square of this thing, you will have x squared plus b by 2a whole squared. And then here the middle term is 2 times x into b by 2a, right? And why did we do this thing here? We divided, how did we get this thing? We divided this by 2, right? The coefficient of x by 2. And then we added the square of that thing on both sides. So that when we do this thing, the 2 and 2 gets cancelled, and you are left with b by ax, which is the same that we need here. So this thing is nothing but this only, right? Is that okay?
B by 2a is okay, but you're multiplying by and 2 is getting cancelled.
Yeah, how do you open the square, this entire square? The
Yes,
formula is a square plus b square plus 2ab, right?
Yes.
So you will have x square here. This is x squared. Then you take the square of this here. And here you have the 2 times
2ab.
x and then b by 2a. So why we take 2a and the square of b by 2a? Because this 2 and this 2 gets cancelled. And then you are left with the same thing that you have here, b by
That's
a.
okay.
That's it.
Okay. I see.
That's why we're adding b by 2a square on both sides. So that this becomes perfect square. And this is equals to b by 2a squared minus c by a. Now, and you have to find the value of it. We're doing all this to solve for x, right? So how do you solve x from here? from this equation. You take the square root of on both sides. So you will get this thing, and here you will get b square minus c by a, and here you have 4a, right? So you would want this entire thing to be greater than 0. We'll discuss this when we look quadratic formula. The quadratic formula actually comes from here. We'll come to this point later when we'll write the quadratic formula. That's like a formula to solve quadratic functions or quadratic equations. And then what you do is you take this to solve for x. You do this, right? B square by 4a minus c by a square root plus b by 2a minus b by 2a. And then you can get the value of x, right? And here you should have plus minus, because when you have, let's say you have x square equals to 4, that means your x could be plus 2 and minus 2 both, right? Putting x2 here and minus 2 both gives 4. That means you should have plus minus here. And if you see something like this, these are notational things. If you have this thing, this just means 2. So when you see the square root of 4 written, this is just the positive one. If you want to express both the negative and positive possibilities of this, x square equals to 4, you write it as square root of plus minus square root of 4. This just means the positive part.
Ma'am, here it is a ma'am. Ma'am, 4a square or 4a?
What?
It is a plus minus under root b square upon 4a square, I think.
Yeah, thank you. We have a square. Thank you. This is the square here. This is b square by 4a square. So this is how you use the completing the squares method to find the value of x, the root of the quadratic equation. Let's do an example on this. So let's take this one, 2x squared minus 8x plus 3 equals 0. If you use the completing, the first step is you divide this entire thing by 2, right? So you'll get x squared minus 4x plus 3 by 2. And then you take this one on the other side. So this gives you x squared minus 4x equals minus 3 by 2. Then you try to make this a perfect square, this thing a perfect square, by adding and subtracting for the coefficient. Okay, what do you need to do? First, you consider the coefficient of x, which is 4. Then you divide it by 2, and then you take the square of it and add it on both sides. So the coefficient of x is minus 4, and if you will divide it by 2, you will get 2, and you will have to add the square of 2 on both sides, right?
Which is
Add 2 square on both sides. So you will get x square minus 4x plus 4 equals 4 minus 3 by 2. Now this is the square of x. This is a perfect square. It's square of x minus 2, right? Because you've done things this way, you can just take the square root of it, this coefficient, and that is 2, right? So this will be this entire thing can be written as x minus 2 square. And then this is 5 by 2. So this will give you x equals square root of 5 by 2 plus minus, and here you have 2, right? This should be your solution. Let's try another example. Just 1 second. Let's do this one. 5x square plus 20x plus 6 equals 0. First, you divide this entire thing by 5. So you'll get this. Then you take this thing on the other side. What should I add here now on both sides?
Four.
Right. This becomes the square of x plus 2. And this becomes 20 minus 6, which is 14 by 5. And then you can solve this, right? This will be. Does anyone have a problem with how we write this thing as this x plus 2 whole squared? Anyone who's not familiar
Yes,
with
it's
this?
No,
valid.
ma'am, no.
Okay. This is x plus minus 14 by 5 plus 2. We know that it has two roots, right? Quadratic equation has either it has, okay, we'll discuss that too. So the two roots are 2 minus root 14 by 5 and 2 minus plus root 14 by 5. Now, when you have a quadratic equation, your complex roots, not just for quadratic equations, for any polynomial, though we're not discussing polynomials right now, complex roots appear in conjugates. That means if you have a root, your complex numbers look like this: a plus iota b, right? Where iota is square root of -1, right? So this is the general form of complex numbers. And if one of your roots is a plus iota b, is a root, then a minus iota b should be a root as well, right? Now we know that if you have a quadratic function, you can only have two roots, right? So either both of them will be real or both of them will be conjugates, complex conjugates of each other, right? If you have one complex root, the other root should be complex as well. If you have one root real, then the other root should be real as well. We can see that from quadratic formula also that we'll do after this one. Before that, let's discuss one more thing. Let's say you have our general when we try to plot the curve, let's try to plot before moving to the last method, which is obviously the quadratic formula.
Ma'am,
Let's
can you
discuss how we plot.
explain more about this conjugates identity lesson? Um,
Yes, ma'am. Once more.
About what?
A
conjugates.
plus IB.
I can't hear you guys clearly. What's your doubt?
Conjugates.
Yeah, we'll come to this point later. Let's first try to plot the quadratic graphs. We'll come to this one after plotting. Then it will be more clear, right? Okay. So let's try to, when you have to plot the graphs, what you do is either, let's say you have ax square plus bx plus c, and you have to plot the graph of this. And how do you plot the graph of this? First, you find the roots of this, right? For which there are at least three methods. Two we have already discussed, and one is the quadratic formula that we'll discuss after this. So first, you find the x-intercepts. That are the roots of this function. right? And we know our quadratic function either looks like this or it looks like this. That is determined by the sign of A, right? Let's say your A is greater than 0, then it is obviously an upward parabola. That's confirmed, right?
Yes,
Now, what
ma'am.
are the other things that we need to know is, one thing is obviously the vertex, which is obviously known, which is minus b by 2a, right? That also you can figure out from the equation itself. Now, what else do we need? We need to find the roots of this equation, right? We don't know if it cuts the x-axis. Okay, it's before the plotting. Let's just get done with the how to find the roots. So we'll do things in this order. First, we'll discuss the last method to find roots, which is quadratic formula. Then we'll discuss the plotting. After this, we'll discuss plotting. And at last, we'll discuss the complex conjugate roots, which is not important for now because we'll be discussing this in the polynomials week anyway. Complex conjugates. Let's first discuss the quadratic formula. So quadratic formula is, we already had this form, right? Last, when we were doing completing the squares, we had this form where we found that your x is equal to plus minus so if this is your polynomial, then x is equals to plus minus b square by 4a square minus c by a minus b by 2a, right? This is what we got. So x should be equals to minus b by 2a plus minus square root of b square. Let's do this thing here. So if you take, this is 4a square, right? First you take the LCM of these two, and then this will be minus 4ac. Is this thing okay to everyone? We just simplified this thing in the square root.
Yes.
Okay.
Yes, ma'am.
Then next you take, this is the same as minus b by 2a plus minus square. This square root is with all of it, right? And now we're doing b square minus 4ac, and we're taking 4a square out of this root. So you'll get 2a. So this is the same as minus b plus minus square root of b square minus 4ac by 2a. That means the standard form for x, where your quadratic equation was this, ax square plus bx plus c. Then the solution to this equation should be x equals to minus b plus minus square root of b square minus 4ac divided by 2a. Now this gives you two things, minus b minus square root of this and minus b plus square root of these, right? These are two numbers. Okay, let's do one example on this one. Let's take this 4x square minus 4x plus 7 equals 0. So formula is minus b. Your minus b is, from here your b is equals to minus 4, a, c is equals to 7, and a is equals to 4, right? So if we substitute the values here, we will have x equals to 4 plus minus square root of b square, that is 4 square, minus 4 times a, which is 4, and c is 7. And then here you will have 2 times 4.
Right.
This is 4.
Will be complex.
Okay. This is 4 plus minus 4 square. 4 square can be taken common, which is 16. And this is 1 minus 7, which is minus 6. by if you have a negative sign here, whenever you have a negative in this thing is called iota. We know that there is no number, no
Complex
real
number.
number. Yeah. We know that there is no
Ma'am,
real
again,
number. Sorry, what?
and this again, the I part.
Yeah. What happens is when you take the square root of, let's discuss square roots, right? What are square roots of numbers? Let's say you are trying to find the square root of a. Square root of a basically means a number which you which when squared gives you a, right? So you need that number x. Now in this case, you say that x is square root of a, right? So if you have 4 here, we know that x is going to be 2, right? 2 square is 4. And when we say square root, we generally have, this is just terminology. When we say square root, we generally mean the positive square root. Otherwise, it's mentioned. So if you have 4 here, we know x is going to be 2, right? How do you find that? You'll have x square equals to 4, and then either you can factorize them, and you can, in fact, from here you can directly see that x equals to 2 and x equals to minus 2 satisfies this equation, right? But if you will have this thing here, x square equals to minus 1, then there's no real number, no real solution of this equation. Can you see that there is no real number which satisfies this equation? Because squares of numbers are always positive. If you take a positive number, the square of that number is positive, and if you take a negative one, the square of that is also positive, right? So you can never have a negative number as square of something. So what we do is, as notational, if you take the square root on both sides, you'll have x equals to square root of minus 1, right? But we don't know what this number is. So what we do instead is, we take this to be iota. To be precise, you'll have plus minus here. And you should have, and this square root of minus 1, we call iota, right? This is just notation for square root of minus 1. So your iota is nothing but it's just notation for square root of minus 1. And when you have iota involved, then these, your real numbers are just these, right?
Sorry,
What?
Bhajan. You just mentioned that iota is nothing but the square root of minus 1. Is that the only thing to mention that, as anything more than for the iota is in any other context it also works?
That's the only thing here. Iota is the square root of minus 1. That's all.
Okay.
So when
Thank you.
your complex numbers, when you discuss your complex numbers, these are collection, these sort of numbers, a plus iota, right? Because you can have something like 2 plus, that's also a complex number, because this does not belong to real life, right? Iota here, iota is not in real numbers. So
Okay.
every number of this form, this collection, where AB is real, is the collection of complex numbers. This is called the collection of complex numbers. That's what happens when you have negative thing inside your square root. So why are we discussing this entire thing? Because we have negative. When you solve this thing, you will have 4 plus minus. You can have the square root of 16 is 4. So you can take this out, and then you will have square root of minus 6 by 8. So you can write this thing as 4 plus minus 4 square root of 6 and iota. But that's not needed. You don't need to write iota and all. This is enough. So what we're discussing here is that you have a negative thing in the square root, and there is no number, no x, whose square is negative. That means this is going to be an imaginary number. This belongs to this, or in simple words, you don't even need to know about complex numbers. This is something extra than a proof. This does not belong to real numbers. That's
Okay.
the whole point is that this entire thing, this thing, where you have a square root of negative number does not belong to real numbers. That's all.
So currently,
Thank you.
we don't deal with complex numbers.
Thank you.
Yeah, we don't need to deal with complex numbers in our syllabus. So this is how you this was for you to apply the formula. This was an example where you could see how you apply the formula. Shall we do one more example on how to apply the formula, or is it
One more, no issues.
okay? Let's do one more example. Let's do some example that we've already done. Let's take this one: x square plus
Using
2x
which method, ma'am?
minus 24, using the quadratic formula.
Okay.
Or shall we do it by every method? We can do it. This is one of those questions which can be done by every method. What happens is factorization usually doesn't work when you have something like, let's say you have something like something in square root, or you can't guess numbers, right? The point is, if you have the roots in square root, let's say one of your roots is root 3, then how does our factorization method works? It says alpha beta such that the product is, now your alpha beta are going to be in square root and you would not be able to guess those numbers, right? Let's say if this is 9 and your alpha beta turns out to be root 3 root 3. Can you guess that alpha beta could be root 3 and root 3? Or root 3 or minus, let's say your alpha beta turns out to be 9 and your alpha plus beta, this gives you 0. Now this is root 3 and minus root 3 satisfies this, right? So it's, or in fact, in this one you can still guess. There are a lot of cases when you can't guess numbers because your factorization method is entirely based on hit and trial, right? You can't possibly apply hit and trial to every question. That's why factorization method fails at a lot of places, at a lot of complicated quadratic equations. Although it's going to work for this one. The factorization method will work for this particular question. But let's do it. Should we do this question by all the three
Quadratic.
methods?
We should do with quadratic, I think.
Okay, let's do it by quadratic formula. Your quadratic formula is x equals minus d by 2a minus d plus minus square root of b square minus 4ac by 2a, right? And here your a is 1, b is 2, and c is 24, minus 24. So if you'll apply this thing, you'll have minus b, which is minus 2, plus minus square of b, which is 4, minus 4 times 1, and into minus 24 by 2 times 1. So this gives you minus 2, 4 plus this, right? Gives you minus 2 plus minus 10 by 2. So there are going to be two roots from here. One is minus 2 plus 10 by 2. The other one is going to be minus 2 minus 10 by 2. So this one is 4 and this one is minus 6. And if you look at these two numbers, actually, okay, use that thing. So your roots are going to be x equals to minus 6 and 4. Using the quadratic formula. You could do it other methods too. You'll get the same answer, obviously. Is this okay? Can we move to the plotting part now?
Yes, ma'am.
Okay. Before plotting, let's discuss this one more thing that we have about quadratic functions. So in your quadratic function, this thing, b square minus 4ac, this is called the discriminant. And the nature of your roots depend on this discriminant b square minus 4ac. So there are cases to it. Let's say the first case is when you have b square minus 4ac. the formula is x equals to minus b plus minus square root of b square minus 4ac, right? And this b square minus 4ac is called the discriminant by 2a. So if this thing is greater than 0, as we've discussed, if this entire thing is greater than 0, then your square root, then you can find a real number, right? This thing will be a real number then. If your b square minus 4ac is greater than 0, this implies square root of b square minus 4ac is a real number. Now this will mean, and we're saying that this is strictly greater than 0, that means this thing is not 0, right? So solution will be minus b plus square root of b square minus 4ac by 2a, and the other solution will be minus b minus square root of b square minus 4ac by 2a, right? Now these are going to be real numbers. This is real. Why? Because minus b is real, 2a is also real, and this entire thing is also real, right? And the sum and the division, the quotient sum and all of it of real numbers is real, right? That means this thing is going to be real, a real root, and this is also going to be a real root, right? Both of the roots are real numbers. So the b square minus 4ac is greater than 0. The first thing is you have two roots and both of them are real roots. And the second thing is that they're both going to be distinct. Distinct as in this is different from this root. Why? Because if minus b plus square root of b square minus 4ac by 2a, this first root is equal to the second root, this would imply, now this and this gets cancelled, right? Because whenever you write, okay, very important thing that I forgot to mention while discussing this entire thing is, whenever you, let's go to the start, very important thing that I forgot to mention here is your a should never be 0. So if your a is 0 here, if you take a 0 here, then this thing will become bx plus c, right? And this is just linear function. Bx plus c is a linear function. So for this thing to be a quadratic function, it's very important that your a is non-zero. Very important condition. So from here, because your a is non-zero, so we can cancel it from, obviously that's why we can write it here in the first place. This means your minus b plus square root of b square minus 4ac is the same as minus b minus square root of b square minus 4ac, right? And from here, your minus b gets cancelled from both sides. And if the square root of two numbers is equal, this is it. This is b square minus 4ac, and this is negative of b square minus 4ac, which means your 2 times square root of b square minus 4ac is 0. Now this should mean your b square minus 4ac square root is 0. And are there any non-zero numbers whose square root is 0? It's not possible, right? That means your b square,
How 2 times of b's root of b square minus 4 is 0.
okay, you have this thing, right? This is like x, or let's say k. This is like k equals to minus k, right? Positive of this number is equal to negative of this number, right? This is the same, where your k is equal to square root of b square. If k is equal to minus k, then this would mean on, you will take k on this side, so you'll get 2k equals 0, right? That's what we've done. We've taken this thing on this side. Minus b minus square root of b square minus 4ac, we've taken to this left hand side. Is that okay?
Just explain again with the k example. Get it?
If you have k equals to minus k, this means just add k on both sides, right? We can do that. So you have 2k equals to 0. Right?
Yeah.
Alternatively, you can say that you bring minus k to this. That's what you do, right? When you have a negative thing here, You take it to the other side and it becomes positive. That's why it becomes positive, because you add positive to both sides. Add k here, add k here. This becomes 2k equals 0.
Okay, okay.
That's what we've done in this one.
Yeah, I connected. So, got it.
Have this thing 0. Now, if you have, for this one, if you have 2k equals to 0, obviously, if you have two numbers and the product is 0, one of the numbers has to be 0, right?
Yeah.
2 is not 0. That means this thing should be 0. And for this one, you'll have b square minus 4ac equals to 0. That's what I was discussing. If you have square root of a number equals 0, are there any numbers whose square root is 0 other than 0? Right? Because this simply means your k square is equals to 0. This is right. So only 0 square is 0 and 0 square root is 0. That means your k should be 0. So you're here. Now we have, in our condition initially, when our case started, we already mentioned that b square minus 4ac is strictly greater than 0. What does this mean? Strictly greater than means it cannot be 0 and obviously cannot be less than 0, right? But here you're getting this thing equals to 0, which is a contradiction, right?
Which is a
You're contradicting what you
What is
assumed
said.
initially. What does this mean? That what you've done here should not be possible. What happens is, if you start with something false, and if this results in a contradiction, it might not result in a contradiction, but if you start with something and you have made no assumptions while you've done this entire thing, and this leads to a contradiction, that means what you started with is incorrect, right? Because we've made no assumptions while we were doing this, while we were coming from here to here. Like in this particular example, when we've taken this, we started with this thing. We started with if these two are equal, right? And then we derived that if these two are equal, then this should happen, right? B square minus 4ac should be 0. But if you started with something and it led to a contradiction, that means that something is incorrect, right? Because we've made no assumptions. We've just done basic arithmetic in between. This is just solving. We've not assumed anything here. That means your two roots can't be equal. These two can't be equal. Two roots are distinct. And we already saw that they are real, right? And real. So what does our case say? It says precisely if your b square minus 4ac is greater than 0, this should imply roots are real and distinct. Now coming to your second case, let's say a b square minus 4ac is 0. And let me just write down the formula too. Some of you might not remember it. So it's this x minus b plus minus b square minus 4ac. And you're saying that this time this thing is 0. You're taking this thing to be 0. That means your x is going to be minus b by 2a plus minus 0, right? That means it's minus b plus 0 by 2a and minus b by 2a, minus 0 by 2a, right? Which gives you the same thing, minus b by 2a from here and minus b by 2a from here. That means obviously your roots are real because your b was real, a was real, and so there obviously the algebra is also real. Algebra of real numbers is real, provided you have not taken 0 in the denominator, which is true. We're not taking a to be 0, right? Initially, we mentioned that a is non-zero. That means this is a real number. This is also a real number. That means if this happens, both roots are real and equal. And then finally you have case 3, which is b square minus 4ac is less than 0. Now if this happens, and looking at this formula, you would have a negative value in square root, right? And that's not a real number. That means your x,
Case of
so this
complex.
would simply mean then you'll have complex roots. What you'll have is something like this, minus b plus square root of, let's call this d because this is the discriminant, right? Square root of d by 2a and minus b minus square root of d by 2. Now this is complex. Okay. We should instead say that this does not belong to real numbers. And this also does not belong to real numbers. Let's not get into complex things. So both of them don't belong to real numbers, right? Because here also root d is not real. Here also root d is not real. So this means you have complex roots, or you can say no real roots exist. And then let's come to the conjugate pairing that we were talking about.
Ma'am, before we move, one quick question.
Yeah.
Ma'am, where you considered 0 for under root b square minus 4ac, right? So not necessarily I think we should, because let's say for an example we are having root 4, so it will be 2 plus 2 and minus 2. Again we'll be getting like unique root, right?
I didn't get your question.
Let's
What's your
say for an
question?
example you are considering b square minus 4ac as 0, right?
Okay.
So even if we don't consider this as 0, and if we solve this, let's say for an example we are getting root 4,
Okay.
right? So it will be either plus 2 or minus 2, right?
This, right?
So in this case we'll be getting one real root, which will be unique.
No, it won't be unique. You will have minus b
Hmm.
by minus b plus square root of 4, which is 2, right? So you will have minus b plus 2 and by 2a and minus b minus 2 by 2a. And these two are not, the root is only going to be unique if both these values are equal. And they'll only be equal when your minus b plus 2 is the same as minus b minus 2. Right?
Perfect. Got it. Thank
Here
you.
you'll have, this will get cancelled and it's not possible. See, we have a contradiction here too. You have 2 equals to minus 2, which is never possible. Right?
Got it.
So, all in all, if your b square minus 4ac is 0, then you only have real roots and both of your roots are same. You have real and equal roots.
Mm-hmm. Okay.
Okay. Let's come to complex. This is again not needed complex conjugates, but you will need these concepts in polynomial week, the week in which we'll be discussing polynomials. Complex conjugates are, we know our complex numbers look like this, right? And for context, your collection of real numbers is also in the set of complex. So if you have 2, 2 is also a complex number. Even if iota is missing, the complex numbers are these, right? Collection of complex numbers is these, where A and B are real numbers. That's, so you can take B to be 0, right? Then you will just have a real number. Take A equals to 2, B equals to 0. Then you will have 2 plus 0 iota equals to 2. That means your 2 is also a complex number. So the collection of real numbers is a subset of complex numbers. First thing is this. And then let's say you have a polynomial, or let's take quadratic function, right? Because everyone's not familiar with polynomials. Then first thing is quadratic functions can only have 2 roots, right? You cannot have, if you have ax square plus bx plus c, then the maximum number of roots it can have is 2.
Yes.
Cannot have more than 2 roots, right? So if if both roots, we've already seen this in examples. First case was when both the roots are real and they are and they're distinct, right? So one was minus b plus square root by 2a, the other was minus b minus square root by 2a, right? So these were distinct roots. That's one case. Then the other case was when both roots are same, and then the last one was when there are complex roots, right? So if you have one real root, let's say if you have one real root, that means the other root is also real, right? Because from the cases we have done, we've seen that if you have what can you have? Two real distinct roots, or you can have two real equal roots, or you can have no real roots. That's the only possibility, right? So if you have, so it's not possible for you to have only one real root, right? Either both the roots will be real, which is the case in these two, or no root will be real. That means both of them are complex numbers. By complex, I meant both of them are not real, right? And the other part we were discussing was if a plus iota b is a root. This is again not needed. You won't be asked questions like these. This implies a minus iota b is also a root. And if a minus iota b is a root, then this implies a plus iota b is also a root. These are called conjugates of each other. So your conjugate of a plus iota b is a minus iota b. That's the definition of conjugates. That's why we say that your roots of polynomials always appear in conjugate pairs. So if a plus iota b is a root, a minus iota b is also a root. That's it. And you
So
can also see it from
real
here. When you have minus b plus minus square root of b square minus 4ac, and let's say this is negative, then you'll have, if this thing is negative, then what would you have? You'll have, that means 4ac minus b square is positive, right? So you'll have 4ac minus b square root iota plus minus b. I forgot the divided by 2a part.
No, what is iota? I never heard this before.
Forget about iota. That's not needed. It's not in the syllabus. And if it's confusing you, you only have to keep one thing in mind, which will help you in the next week. It's not in this week. In this week, what the cases we've discussed so far, they're enough. This might help you in later weeks. This one, that if you have a complex root, a purely complex root, okay, we'll discuss this entire thing in next week only. This is just extra for this week. We don't need this. Is that okay?
okay,
Yes,
you
ma'am.
can explain what you are explaining.
What?
The real root part you were explaining.
If it was related to this one complex part, then we don't need it. And we're done with all the possible cases here. So I don't think we need any explanation in this part.
Okay.
Any part of this which is needed, it's needed in the polynomials week, and we'll discuss that in the polynomial weeks. Don't worry. Okay. Let's do one example on each of these. When you have b square minus 4ac greater than 0, let's do a quick example. Let's do this. 2x square minus 4x minus 1 equals to 0. Now, if you'll find b square minus 4ac for this, these are examples, and this is for case 1. So if you'll find b square minus 4ac, it's 16 minus 4 times a, which is 2, and minus 1 here. So it will be 8, right? So here you will have square root of 24, and in the roots you will have plus minus 24, right? Because your b square minus 4ac is greater than 0. This is greater than 0, right? This is, that means you have two real roots, real distinct roots. And those real distinct roots are, one is 4 plus minus square root of 24 by 4. And 4 minus square root of 24 by 4. Let's do one example on case 2, where we need b square minus 4ac 0. So let's take,
It should be minus b, right?
where,
Minus 4
yeah, it's
plus root
minus
20.
b, right? B is 4, so minus b is minus 4, so b is minus b is 4.
Minus of minus 4 will be 4. Yes, ma'am, it's right.
Okay. Let's take one example, this one, where you have this. If you try
Please
to
solve
find,
solve in detail if it is possible.
okay,
Before
let's do these in detail.
in that way.
Of quadratic formula was, we're using quadratic formula here.
Yeah, that way more clear.
So b square minus 4ac is 24. That's fine, right? And your x is equals to minus b plus minus square root of b square minus 4ac by 2a. Where your b is equals to minus 4, so minus b will be equals to 4. Plus minus square root of b square minus 4ac is 24. And 2a is 2 times 2, which is 4. So this is just going to give you 4 plus minus square root of 24 by 4. So you have two roots from here. 4 plus square root of 24 by 4 and 4 minus square root of 24 by 4. Is that okay?
Okay.
Then we have case 2. Let's take this example there. X square minus 8x plus 16, right? If you have this thing here, if you'll find b square minus 4ac with this, your b is minus 8, a is 1, and c is 16, right? This will be b square minus 8 square minus 4 times 1 times 16. This gives you 64, and 16 times 4 is also 64. It gives you 0. That means your b square, now if you will apply the formula, it's minus b plus minus square root of b square minus 4ac by 2a, which gives you 8 plus minus square root of 0, because b square minus 4ac is 0, by 2. So this gives you 4. There will be two roots from here. 8 plus 0 by 2 and 8 minus 0 by 2. So it's just simply 4 and 4. Both roots are real in this case, as expected. And then we have case 3, where we don't get a real root. In fact, no roots are real there. Let's take this one. X square minus 5x plus 8 equals 0. Now, if you have this, we'll apply b square minus 4ac here. You get 5 squared minus 5 squared minus 4. A is 1 and C is 8. This is going to give you 25 minus 32, which is negative, obviously. It's negative of 7, right? That means no real roots. So if you try to find the roots of this, they are going to be minus b, which is 5 plus minus square root of minus 7 by 2. So this is 5 plus square root of minus 7 by 2 and 5 minus square root of minus 7 by 2. And both of these roots are complex, or you can these are they don't belong to real numbers. Obviously the other ones were also complex, but these are the ones that don't belong to real numbers. That's the distinction. Is that okay?
Yes, ma'am.
Now let's say if you have ax square plus bx plus c equals 0, and if your c is negative, then we know b square minus and a is positive. That means if a and c have distinct signs, different signs, a and c have opposite signs. One is plus and the other is minus. So it could be a positive, c negative, or a negative, c positive, right? That is a positive, c negative, or a negative, c positive. Both are possibilities, right? If a is greater than 0, c is less than 0. Now your discriminant is this, b square minus 4ac. And if they have opposite signs, that means a is positive, this is negative. That means the sign of AC is or A is negative, C is positive. There are two possible cases, right, that we've considered under this case. This is going to be B square, and this entire thing is going to be negative. AC is going to be negative. This would imply minus 4AC would be positive. And B square, we already know squares are already positive. That means B square minus 4AC is positive. That means if A and C have opposite signs, roots are distinct, or at least they are real. It's quite possible that both of these are positive, right? So yeah, are distinct and real. The nature of roots, it all depends on this discriminant b square minus 4ac. So if a and c have opposite signs, your roots are real and distinct. Now from here you can say that if your roots are not real, let's say, then this should mean that a and c have same signs. Right? If ever your roots are not real, then a and c are going to have same signs. These are small things that you can see from here only, from the discriminant. The discriminant decides everything. So whenever you're asked about nature of roots and anything, you have to switch to this thing. And then the other important thing is when you have a quadratic equation, ax square plus bx plus c types, this is equals to 0. Then let's say alpha beta are roots. then the product of these roots, alpha, beta, is equals to minus b by a, where b is this coefficient of x, a is coefficient of x squared, and we have a negative here. And alpha plus beta is equals to c by a. And c is this constant term and a is the coefficient of x squared. For example, let's say we did this one, right? Where we did x squared plus x minus 6 equals to 0. And the roots of this were one was 2 and the other one was minus 3.
Hmm.
When minus 3, minus 6, right?
Ma'am, alpha plus beta is equal to minus b by a now.
Yes.
But you wrote alpha plus beta is equal to c by a.
No.
So this thing is b by minus b by a, and this thing is c by a. Alpha, beta are the roots, and c and a are the a, b, c are the coefficients here. So, for example, let's say you have this thing. Then the product, we know that the roots are, we've already calculated this. So, this is alpha, this is beta, right? So, alpha plus beta is equals to minus 1. And we say that alpha plus beta, the sum of roots is minus b by a. Let's see what minus b by a is. Minus b by a is minus 1 by 1, which is minus 1. So, it's 2, right? Alpha plus beta, the sum of roots is equal to minus b by a, and then you have alpha into beta, that's going to be 2 into minus 3, so it's minus 6, and we say that this is equal to c by a. Let's see if it's equal to c by a. C by a is minus 6 by 1, which is minus 6. So it's one thing, and now let's discuss the how the graphs look like. Let's say we had a case, we had made 3 cases, right? So first case was when your b square minus 4ac was greater than 0, and you had real distinct roots. What does the graph look like then? Let's say your equation is ax square plus bx plus c equals to 0, where a is not equals to 0. So if you have 2 distinct real roots, that means it cuts the x-axis on at 2 different points, right? So one is, let's say, this point, the other could be this point. That means it either looks like this or it looks like this. And this depends on if a is less than 0, if a is greater than 0, right? Which is if you have b square minus 4ac greater than 0, then the graph of your quadratic equation cuts the x-axis at 2 points, 2 distinct points. Now let's take second case where you had b square minus 4ac equals to 0, and you said you'll have real roots, right? Real and equal roots. That means it will look like this, where this you had 2 distinct roots, right? So these are your 2 distinct roots. And in case of a less than 0, these are your 2 distinct roots. And if you have real and equal roots, that means you only have one root. And it's repeated 2 times, right? That means, and that would be this real root. So a graph will look like this or this. So if your a is less than 0, it will look like this. If your a is greater than 0, it will look like this. For one root. If you have one root which is repeated 2 times, that's what happens when you have real and equal roots. So it cuts your x-axis at only one point, right? It doesn't even cut it, actually it just passes through it. It touches the x-axis at one point. And then you had case 3, where b square minus 4ac is less than 0, which means you have no real roots. So if you have no real roots, that means it does not cut the x-axis at all, right? That means your graph should look like this. Or it can look like this. Or it can look like this. The only point is that this is going to touch the x-axis, right? So it will look like this. These two, depending on a greater than 0 and a less than 0. Because it does not have any real root, that means it should not touch the x-axis at all, right? Now let's come to
the second piece. Just show.
This one.
Done.
Is there any doubt in these 3 cases and how the graph looks like in each case?
Not at all.
Okay. And let's come to this thing where, let's say you have, so if you have your vertexes, we have discussed vertices, right? If your vertex is 0, 0, then your graph looks like this. Y equation looks like this. Y is equal to x squared, right? Because if you have 0, 0 as passing point, you will have ax squared plus bx plus c equals to 0. And then because 0, 0 is vertex of this equation, that means 0, 0 should satisfy this, right? Sorry, I should have written fx here. Y, right? That means 0, 0 point should satisfy this equation. And if you substitute y equals to 0 and x equals to 0 in this equation, you will get 0 plus 0 plus c equals to 0. That means your c is 0. So this will give you ax squared plus bx equals to y. And now what you can do is you can just complete, we've done the completing the squares part, right? This can be solved using completing the squares. So it will be something like this, x minus k whole square equals to y. Can you follow till this point? Is there a doubt till this point? But we're doing things very roughly. But you should know why these things are happening.
Ma'am, where is
Is
this k coming from?
Which one? Or this
K.
actually, because you have wait. Yeah, you should not have a k because then 0, 0 won't satisfy this. So you'll have this thing and yeah. Okay. So but we need this form, right? Y is equals to kx squared. So the other part should also vanish. And
Ma'am, does that mean k is equal to a?
yeah, hold on a second. If you have vertex at 0, 0, your equation looks like this thing. Y is equals to kx squared. And you can have an x here too, but if you have an x here, then you have kx. Let's say you have, if this is your vertex, that means ax square plus bx. Now if you take x common from here, you'll have x, ax plus b, right? And if you solve it, you'll get x equals to 0 and x equals to minus b by a. Now that means your curve is going to get cut into two. It's actually not possible. Because have you checked the forms, when you find the solution of a quadratic equation, let's say this was your initial quadratic equation, then there are only three cases. One case is when you have, if one of your roots is 0, let's say, that means minus b plus minus square root of b square minus 4ac. This thing is 0, right? Now this should mean, and because both, okay, that's possible, right? The point that I was trying to make was, if you have 0, 0 as vertex, then your function looks like this. Y is equals to kx squared. And this is when your vertex is, you can also call it cx squared. This is when your vertex is 0, 0. Now, if you have vertex shifted to AB, we'll come to, there's a little confusion here. If not AB, AB is already taken, right? Let's say you have your vertex at x1, y1. If this is the vertex, then your function should, okay, let's first discuss this thing only, because it's this one, why you're going to have y is equal to cx squared. So if you have vertex at 0, 0, that means,
Now, is it coefficient of x equals to k?
sorry, what? What's your question?
Ma'am, is this coefficient of x equals to ax square? K.
Yeah, this is the coefficient of x squared.
K.
The k I've removed, right? Okay, let's keep, because c is already here, let's keep k here. The point is, if you have 0, 0 as vertex of your quadratic equation, your quadratic equation looks like this, right? What does vertex mean? Vertex means it's a point. If your vertex is 0, 0, that means your minus b by 2a is 0, right? Vertex is minus b by 2a, if you remember, and f of minus b by 2, right? So if your vertex is 0, 0, that means minus b by 2a for this equation. Let's forget this for now. Let's say your vertex is 0, 0. Then we saw that c has to be 0. Now let's come to a and b. Why b has to be 0? Because minus b by 2a is the point of the x coordinate of your vertex, and that's given to be 0. X coordinate of your vertex is 0, right? And your x coordinate of vertex is given by minus b by 2a. That means your b should be, this should imply that your b is equals to 0, right? Now this would mean that your y is equals to just ax squared. Is that okay? What's the conclusion for you? The conclusion is, if 0, 0 is vertex, then vertex of a quadratic equation, this implies your quadratic equation is y equals to ax squared. The coefficient of x is 0, and the coefficient of the constant term is also 0. We've seen why both of them are 0. We've seen why c is 0, and we've seen why b is 0. Is that okay?
Can you explain
So,
this?
okay. Let's say you have vertex 0, 0. Vertex means, we already discussed this, your vertex is vertex of ax square plus bx plus c equals 0 is minus b by 2a, and f of minus, if this is fx. If this is your given function, then it is this point, right? Or graphically, if you look at it, it's this point where your axis of symmetry, this one, if you draw parallel, if you draw a line passing through this point parallel to y-axis, this will be your axis of symmetry, which is also equals to x equals to minus b by 2a, right? This line is x equals to minus b by 2a. We discussed this. This was axis of symmetry. And where this line intersects this quadratic function, that's your point of vertex. And this point precisely is minus b by 2a and f of minus b by 2a, right? This says that your vertex this time is 0, 0. Now, if your vertex is 0, 0, that means your function, this is the vertex. That means either it should be this or it should be this, right? Is that okay?
Yeah.
Now, what does this mean? How many roots do you think this is going to have? Both of these. Doesn't matter. If a is greater than 0, then it looks like this. If a is less than 0, it looks like this. Because it intersects x-axis at only one point, that means it can only have one root, right? Which is x equals to 0. That's the only root possible for this function.
Yes, ma'am.
That means if at all you have, okay, so the only root is 0. This is the observation geometrically, graphically. And then if you do it algebraically, you will have, let's assume your equation to be ax squared plus bx plus c equals to the function, right? Y is the function, fx, right? This is how you write functions. You say that 0, 0 is a vertex. That means 0, 0 is on the graph. That means 0, 0 satisfies this equation, right? Put y equals to 0, x equals to 0, you will get c equals to 0. Is this still point clear to everyone?
Yeah.
Ma'am, one thing I just want to ask is like you wrote minus b by 2a and function of minus b by 2a. So when it is the same, we so why it is function? So it is little bit. If you could throw some light on this, that'll be great.
Okay, when we say that the point of intersection is, let's say you have fx equals to ax square plus bx plus c, right? And you say that the x coordinate of vertex is the point. This graph looks like this. Let's say that it looks like this. Then vertex is this point, right? And it has two
Yes, ma'am.
coordinates, x coordinate and y coordinate. So the x coordinate is minus b by 2a of this point. And how do I find the y coordinate?
Same, right?
Okay. Let's say you have this this line. Let's say you have y is equals to 2x line. Now, if your x is equals to, let's say, you have this point where your x is equals to 1, right? Now, this point has two properties. One is that its x coordinate is 1, right? And the other property is it lies on this line, right? So if you have to find the y coordinate of this, let's assume it's y naught. That means 1 comma y naught should satisfy this line because it lies on this line, right? That would mean you should have y naught equals to 2 times 1 because 1 comma y naught satisfies this line. It lies on this line. That's why. That means your y naught should be equals to 2, right? That's how you find y. When your y is missing and x is given. Now, how do you find y here? Let's say you're saying minus b comma 2a and y naught. Y naught is, we don't know what y naught is yet, right? We'll find it. So if this point satisfies this function, if this point lies on this function because it's vertex, that means it's going to lie on this function, right? That means this point should satisfy this line, this function, right? That means your y naught should be equals to a minus b by 2a squared plus b minus b by 2a plus c, right?
Yes, ma'am.
Okay. That means this is the required point. Now, instead of writing this entire thing, can I not simply write that I am substituting minus b by 2a in this function, right? That's what I'm doing, right?
Yes.
That's why we've written this to be equal to f of minus b by 2a.
Okay,
Instead of
ma'am. Thank you.
writing this entire thing, this is too long, right?
Yeah, okay.
Okay. So you have 0, 0 as vertex. That means first thing is we saw that your C has to be 0, right? And then because vertex is given by minus b by 2a and minus f of minus b by 2a. So vertex is given to be 0, 0. And the general formula for vertex is minus b by 2a, comma f of minus b by 2a. If your given function is ax square,
F of minus b by 2a is little.
vertex of ax square plus bx plus c, fx equals to this. This is the vertex. If you have this function, then the vertex is given by this. And your vertex is given to be 0, 0. And you have to find this, right? You have to find the equation of this. So how do you proceed? First thing is, you know 0, 0 is a vertex. That means it should satisfy this equation. From here, you get c equals to 0. Second thing is, you know that 0, 0 is the vertex. And formula for vertex is minus b by 2a. So if your quadratic equation is this, then minus b by 2a should be equal to 0.
0.
This will give you b0, right? That means b is also 0, c is also 0. So you're only left with ax squared.
Why is
That's
it
why,
true?
is this fine to everyone?
Yes, ma'am. That I
Does
wanted.
anyone have a doubt in this thing?
No, no.
No, ma'am.
Okay.
Thank you.
That means your if your vertex is 0, 0, then your function will look like this. Your quadratic function will look like this if vertex is 0, 0. Where we don't know what a
B
is.
and C both are 0, right?
Yeah, b and c both are 0. But we don't know anything about a yet, right? So this is the point. I've written it here. And then let's say you're shifting. So it and the graphically it looks like this. If a is greater than 0, because it passes through 0, 0, it looks like this. And if a is less than 0, I should write over here. Or this, if a is less than 0, right? Now let's say you're shifting instead of vertex 0, 0, if you take vertex equals to x naught comma y naught, then how should your function look like? We know when the vertex is 0, 0, it looks like this, right? And equation is y is equals to ax when vertex is 0, 0. Now if your vertex is this, then this looks like this. The equation looks like this, y minus y naught equals a x minus x naught squared. And how can you remember this thing? When vertex was 0, 0, you had y minus 0 equals x minus a times x minus 0 squared, right? Which is y is equals to ax squared. Now, if you have x naught, y naught, then your function, the quadratic function should look like this. Y minus y naught. And what we're doing here graphically is, let's say a is greater than 0. Then for 0, 0 vertex, it's like this, right? And when in any function, let's say, this is not just for quadratic function, this is for any function. If you have y is equals to fx, and you do y minus a and fx minus b, or y minus y naught, fx minus x naught. then what happens is, have you heard of sine functions? This one.
Yes, ma'am, that's sine trigonometry.
So if you have this thing, and instead, let's say you take y minus 1 or y minus y naught equals sine x minus x naught. Then the graph, then this, every point on this graph, no, the graph of this looks like this.
From that upward
Yeah,
wave
it
like.
gets shifted. This point, so your y coordinate, if you have y minus y naught, so if the graph of this looks like this, then the graph of this thing, what should it look like? Because you've shifted y coordinate, this means you've shifted y. If this is the point, then this point gets shifted here. Y naught units upward and x naught units to the right. Minus x naught means shift this 0, 0 point to x naught units on the right. And minus y naught means shift this point to upwards. So that means this point will get shifted here. If this is y naught point, this is x naught point, then your 0, 0 point gets shifted here. X naught comma y naught. So that means, and similarly, every point gets shifted by y naught units upwards. So this point gets shifted by y naught point units upwards here, y naught units, and x naught units to the right. So this point gets shifted here. This is x naught units. This is y naught units. So this is a very complicated function. I know this you might find a little difficult, but this one's just easy. So if you have 0, 0 here, your vertex gets shifted to, now if this is 0, 0, we know if I do minus y naught, then this shifts every point on this y naught unit upwards, right? So where will 0, 0 get shifted? This point, okay. If the shifting part confuses you, you can just remember this as a formula that if you have y is equals to ax square, this is what the graph looks like. And if you have y minus y naught equals ax minus x naught square, which is possible for you, every quadratic function whatsoever can be expressed in this format. Right? We'll do that too. We'll do an
Ma'am, when
example.
you say it's shifting upwards, right? Because it
Yeah.
has two real roots.
No, it
Is
has
that what you're
nothing to do
saying?
with, no, it has nothing to do with real roots, but it is shifting origin. That's it. This is called shifting points. 0, 0
Okay.
gets, because you have minus y naught. Okay, let's not go there. We don't have enough time to discuss that, and that's not even important. What's
Okay.
important is, this is just a quick, it's like a quick trick for you, that you can write your quadratic function in this format. Firstly, you will see that every quadratic function can be written in this format. And secondly, once you're able to write it in this format, then you can decide what the graph looks like. You can quickly tell from here what the graph looks like. Let's do it with an example only, because I think a lot of alphabets are a little confusing. So let's say you have, give me a quadratic function.
Ma'am, do we have anything wherein we can study, we can read something about these? Any book that you can suggest?
Right now, I can't think of any book, but I'll let you know if I come up, if
Okay, thank you.
can remember a name of some book. Okay. Let's do this thing. Let's do the example that we've been doing repeatedly. So let's take this one. Right? If you have this as function, let's say you have this as function, then we said that every function can be written in this format, right? Where this is y. Fx and y are the same things, right? So I claimed that I can write this thing in this format, y minus y naught and ax minus x naught whole square, right? Let's try to write it. We have, this is similar to completing the squares. So you'll have x squared plus x, and then I can have half here, and the square of half, this will be 1 by 4 minus 1 by 4 minus 6. This is similar to completing the squares, if you can see. And from here you will have y equals to, this is x plus half squared minus 1 by 4 minus 6, right? And then you can take this entire thing on the other side. So you will have y plus 1 by 4 plus 6. So this is 6 for 24 and 25 by 4 equals x plus half squared. So I said you can write it. Now can you quickly compare this with this and tell me what's y naught from here and what's x naught from here. Compare these two. We claim that every quadratic equation can be written in this format. Now I've written it in this format for you. Tell me what's y naught from here and what's x naught. You'll compare this with this thing. It still looks a little different from this, right? Let me just write y minus 25 by 4 equals x minus half squared. Now can you guys tell what's y naught and what's x naught?
Y
Y
naught
naught
is
is
minus
minus
25 by
25 by 4.
minus 1 by 2.
and
X
minus
naught
1
is
by 2
minus
is
half.
the x naught.
Yes, minus half.
Now let's plot the graph of this. This means your vertex is at. Now this also gives you your x naught if you have your function, because I know every function of this form. Y equals to, let's take it here. Y equals to ax square plus bx plus c can be written in this format. And now what does this give you? Your y, and in this case your x naught y naught is the vertex. So if you can write the quadratic function in this format, which you can for every function, for every quadratic function, then x naught y naught gives you the vertex. So you can just quickly draw the graph. You can just check if k is positive or not. That will give you this thing, whether it's upward or it's downwards. And for x naught y naught, you will have the vertex from here. So if you have here, let's say this is your x naught y naught point, and k or a is positive, then it should look like this. And if it's downward, then it should look like this. Is that okay? Now, what does this help with? It helps with, let's say you've been given y is equals to y minus y naught is equals to x minus x naught squared. If you've been given this form or something similar, or you've been given y is equals to x minus x naught squared plus y naught, something like this, then you can quickly tell the vertex from here, right? Let's say you have an equation of the form y is equals to 3x plus 4 squared minus 2. And what's the vertex of this equation?
2 and 3.
2 and
Minus
3.
minus 4 and minus 2.
This is the same as this, right? And we said that if you can write it in this manner, y minus, which you can for every equation, plus equals 3 x minus minus 4 square. Then the vertex is, from here you can see it's minus 4 minus 2.
Minus 4 and minus 2.
But this is, if you have been given an equation in this form, ax square plus bx plus c, then don't try to convert it in this form and then find the vertex. Because you have a direct formula for it, right? Minus b by 2a and f of minus b by 2a. Use that formula. That's easier. But if you've been given in this format, then first for you to apply minus b by 2a formula, you'll have to simplify this thing, right? So to avoid the simplification, you can directly find it from here.
Can you explain this formula again?
Which formula?
This, why you use it? Finding vertex.
Okay, let's say you have to find the vertex of this thing. Instead, you have to find the vertex of 3x squared plus 2x plus 1. If you have to find the vertex of this function, then you can directly apply the formula, right? Minus b by 2a and f of minus b by 2a. That's easier instead of writing it in this manner, which you can. It's possible, absolutely possible for you to write this in y minus y naught equals to x minus x naught squared format. It's possible. But why to do so much work when you can directly find it by using the formula, right? So in this case, using the formula is easier. But if you have something like this, let's say you have y like this one. Now, instead of, if you will apply this formula b minus b by 2a, it's going to take time, right? Can you figure out what's b from here? You can't quickly tell what's b, right? You'll have to solve this thing and then check, then write it in ax squared plus bx plus c form. And then only you can tell what's a, what's b, and what's c. So to avoid all that, you can just directly use this thing. This gives you vertex. Write it in y minus y naught form, x minus x naught here. That's it. Is that okay? Then there are a couple of things that you should know. The first thing is, let's say you have x minus a, and x minus a is a factor of fx. Then if x minus a is a factor of fx, what does that mean? That means x minus a divides fx, right? So I should be able to write fx as x minus a, and then here is the quotient when you divide fx by x minus a plus the remainder, right? Are you familiar with this form?
Yes, this is simple division.
Yeah, this is the simple division algorithm where this is your dividend, this is your quotient, and this is your remainder.
No, ma'am.
So this is the divisor.
Divisor
The
into
divisor.
quotient
Yeah.
plus remainder.
This is the divisor and this is the dividend. This is it, right? And the degree of remainder should be less than the degree of divisor, right?
Yes, ma'am.
Degree of Rx should be less than degree of x minus a. What's degree of x minus a? Have you guys done degrees and all?
It is 1, ma'am.
Not yet, right? Okay, so it must be, okay, then this entire thing must be a part of polynomials week. This is
Yes,
one.
ma'am. It's
You study
division
about
algorithm
degrees.
only.
Yeah, the degree of this is 1.
Yes, ma'am.
So your remainder should be constant, right? Okay, I think we have not done this thing. This is in week 4. So let's not do this here. Let's do a couple. Are we left? We're not left with any time, right? We can discuss a few questions if you want, which we'll obviously be doing in later sessions. In tomorrow's session, we'll be doing questions. So should we take up some questions or is this enough?
It would be great if you take one example for y plus y naught and x naught form. If you can explain again from this method, finding vertex.
Okay. The whole point of knowing the vertex this way was, if you have y minus y naught equals to x minus x naught squared form, and there is a coefficient here, right? Then the vertex of this thing, if this is, firstly, every quadratic equation, no matter the form, is expressible in this form. You can express that in this form, right? And secondly, the vertex from here is, vertex have 2 coordinates, right? First is x coordinate, second is y coordinate. So your x coordinate is this. Whatever is subtracted from x is the x coordinate, which is x naught. And whatever is subtracted from y is the y coordinate. So this gives you the vertex of this quadratic equation. Now, if you are given your equation in this format, then you can use directly this formula of y naught and x naught as we discussed. Because if you're given three, we discussed this. What do you have a particular doubt in this? Because we've already done an example on this, right? Let's say you have, if you want to take up one more example, let's take this one. Y equals x three by two x minus 5 squared plus, let's take this one, 2y and 4 here. Let's try to find the vertex of this, right? Then what do? First, you take this thing on this side. So you'll have y minus 4 and you have a 2 here, right? So you'll have to take, wait, let's do it step by step. This is 2y minus 4 equals 3 by 2 x minus 5 squared. Now, while you're comparing it to this form, look closely that the coefficient of x and y, both in this form, are 1, right? And here you have 2. That means you should make the coefficient of y 1 first, right? For it to look like this, make the coefficient of y 1. So you divide this entire thing by 2. Divide both sides by 2. So you have y minus 2 equals to 3 by 4 x minus 5 squared, right? Now you have it in the form y minus y naught equals a x minus x naught form, right? Now what's the vertex of, and let's take, if you have plus, let's take plus here. What's the vertex of this function, this quadratic function?
It's 2 and x plus 4. 1 is 2, minus 2.
Okay, which one is 2?
-5.
Vertex has two coordinates, x coordinate and y coordinate. What's the x coordinate?
-5.
Minus
5.
5. Just write it in this format. It still confuses you. Just, you have to write it as y minus y naught. This is already in the y minus y naught form, where your y naught is 2, right?
Yes, ma'am.
And x minus x naught. So you'll have to take, this is in x plus 5 form. So write it in x minus minus of 5 form, this form. Now you have it in x minus x naught form. 3 by 4 equals y minus 2. So the vertex should be
-5
x, for x
comma
coordinate,
4,
look here, it should be minus 5.
minus 5.
And
comma
for y
2.
coordinate, looks here, it should be, so it's this. Is that okay?
It's fine.
Yes,
Yes.
ma'am.
Got it now.
Let me check if you're missing on something else.
I guess.
I got confused here. As in, when you say minus 5, so y minus
X plus 5 equals
y
0.
minus 2 is equal to 3 by 4. X minus, this is not, I'm not able to make sense of this.
Okay, you've understood this part, that if you have your quadratic function looking like this, if this is the equation you derive from your quadratic function, then the vertex should be x naught comma y naught, right? Where x naught, this is what is subtracted from x, and this is what is subtracted from y, right?
Yes.
Now have a look at this thing. This is y minus 2 equals 3 by 4 x plus 5 squared, right? first thing you need to be very clear of is the coefficient of y and x both should be 1 in this form, right? When you're trying to find the vertex using this form, make sure that the coefficient of x and y both are 1. This is one thing.
Okay.
Second thing is that you should have the y coordinate of vertex is what's subtracted from y. So 2 is subtracted from y. You should have 2 here, right? And the x coordinate of this vertex is what is subtracted from x. What's subtracted? If you have x plus 5, then 5 is obviously not subtracted, right? It's added. So you should have x minus minus of 5. X minus minus of 5 is x plus
Oh, I got it, ma'am, now. Thank you.
should have a 5 here. Minus 5. I think we've tried to cover everything and everything has been covered. Is there anything that's left? I don't think so. But if there's anything that you have a doubt in from the summary, you can ask that. Do we have any doubt in the summary?
I guess. Not at all.
Okay, there is no doubt.
No doubts.
Sorry, it's not technical. I just want to know something like, till now the grades of the week 2 have not been upgraded. Any idea about that?
Yes, ma'am, it is showing evaluation is pending.
What for week 2? Graded assignment?
Yeah,
Yes,
the
ma'am, it
graded
is
assignment.
showing the evaluation is pending. Yes, ma'am.
That's not an issue. That if that's an issue and it's the same for everyone, then it will be resolved.
Okay, thank you.
Will be updated
Yes.
soon.
Okay. Okay.
Ma'am, actually, I had a doubt.
What's your doubt?
Hello.
Yeah.
Ma'am, my doubt is that if we're trying to find roots of a quadratic equation and suppose we get two numbers like 6 or 12, then is there a rule for us to consider alpha and beta as what? Because suppose the question is about finding roots and then they write that alpha minus 10 is equal to some answer and write that numerical answer. So how do we decide whether alpha will be 6 or whether it will be 12?
What's the question? That should not be a correct question then. If you have two roots and that won't be a question. What's the exact question? That is a question that's not correctly phrased. To be precise, if that's phrased that way, then it's incorrectly phrased. But what's the question?
No, just find the roots and one of the roots minus 10 is equal to value, something like that.
That's it.
Yeah, and you have to write the numerical answer for it.
Can you give me the quadratic? Okay, so you have not been given the quadratic equation either.
Yeah.
So it's just this thing, ax square plus bx plus c. This is your quadratic equation, and then they say that it has two roots, let's say alpha, beta. And one of the roots is, that's it, that's the question.
Yeah.
Is it from somewhere from the portal or
no?
Okay. See how far can we do with this information. So one is, okay, we know that the sum of the roots alpha plus beta is equals to, okay, if you have been given this thing, then you're done with alpha, right? If the value here is given to you, then you're done with what's alpha. You can find alpha, right? So you already have one root. That means if you have been given this information, alpha minus 10 equal to some constant, where constant is given, that means your alpha is given to you, right?
Yes.
Can you tell me the exact question?
Actually, I don't have an exact question. I just wanted to know that is there a way that we define alpha's value and beta's value or any two
No, because
random numbers
that's
will
why
put?
I said your question that you've been asking, not only it's incomplete, it's also incorrectly phrased. Because if you will be given this thing, alpha minus this is something, and you've only been given information about alpha, then this relation, this that you have is minus b by a, and alpha beta is equals to c by a. Why this works? Because this is symmetric, right? If you have two roots 10 and 2, then either you write 10 plus 2, you choose alpha equals to 10 or alpha equals to 2, it doesn't matter. Eventually you will have 10 plus 2, 2 plus 10, it's the same thing, right?
Yeah.
That's what I discussed initially when I was discussing this, that both of these things are symmetric. Symmetric means alpha plus beta, beta plus alpha doesn't change anything, right? If you replace alpha with beta, beta with alpha, nothing changes. That's symmetric.
Okay.
Right? This is
Thank
symmetric,
you.
this is also symmetric. That means you
Yeah.
can choose anyone to be alpha, anyone to be beta. That should not be a problem. Unless
Okay.
they have mentioned that this bigger root is to be taken alpha, smaller root is to be taken this, then we'll need to have a question like that in order to discuss that question. Because
Okay.
right now I can't think of a question like that. Is that okay? If you come across any such question from anywhere, we can discuss it in the next two sessions. One is
Okay.
doubt session, the other one is solve with us session.
Okay.
Okay. Anything else?
No, thank you.
Does anyone else have any other doubt?
No, ma'am. Thank you, ma'am.
Thank you,
Okay,
ma'am.
so if we'll end this session here then. Thank you guys.
Thank you, ma'am. Thank you.
Good night.
Ma'am.